So hi, I'm Larissa, this is Michelle.
Hello.
Thank you all in the conference for having us. We'll be talking a little bit about memory leaks today, how to identify them, what they are, how to identify them, and how to get rid of them. So to start, we're going to be covering a few topics, remembering what is ARC, what is a leak, reference types, the main sources of leaks in your apps, how to identify them, a few tools you can use to identify everything, and how to fix them. So beginning with ARC, what is this? ARC stands for Automatic Reference Counting, which is Swift's way of managing memory. So you have a number of references to your object, and it is only deallocated from memory when this reference counts down to 0. So that's how memory management works. And to give you an example, let's say the circle is an object, and we have two variables pointing to it, so two references. If we get rid of one of them, the reference count goes down to 1. And we get rid of the second one, this object's dead. It's now deallocated because you don't have any strong references to it. And I've said strong, so what is this exactly? Reviewing reference types. Strong is the default reference type in Swift. It protects the object from being deallocated by ARC. And it happens because this variable increases the reference count by 1. It can be a let or a var, and it can be optional or not. The fact is, it's going to increase 1 in your count of references. So to give you an example, here we have a variable, a strong reference pointing to it, so a name pointing to an object. This object has a count of 1. Okay, another country, another object with also a count of 1. And here we have a second name pointing to it. So the reference count of this object is 2. Notice that the second one was an optional, but it doesn't matter. As long as you point it to an object, it's going to be a strong reference. Then you have weak variables. What's the difference? I mean, they don't increase the reference count. That means that it doesn't protect the object from being deallocated. And it's going to be set to nil once this object disappears from memory. So going back to that example, we have one strong reference to an object, and now we have a weak reference to the same object. When we get rid of the strong reference, this object is going to be deallocated because only one of these variables increase the reference count. And your weak reference is now nil, so you can access it through your code. You're not going to have a problem because it's mandatory to be optional. So you're just going to get nil and everything's fine. And finally, we have unnamed variables. What's the difference between them and weak variables is that they're not automatically set to nil when the object's deallocated. But other than that, it doesn't increase the reference count and it doesn't protect the allocation. So what happens is, let's say, again, the same example, we have a strong reference to an object, so count 1. Then we have 3 names pointed to it in total, but only one of them is a strong reference, so the count is still 1. When you deallocate it, the other 2 names that pointed to it, that were unnamed, they still point to a point in memory, but now there's no object in it. So if you try to access them, you're going to get an error. And you have to be very careful about it in your code, because unknowns are not treated as optionals. So you kind of assume that the object is there, and you have to be very careful with this, because you're going to get an exception if you try to access an unnamed object that's not in memory anymore. So
okay.
Recap.
In this table here, we just wanted to make a recap of the reference types that Larissa just told. So if you take a look on the columns, if you have a variable declared as var, for example, it can be as strong, weak, or unnamed. It's a little different for let variables, just because when you actually, the let variables cannot be weak, because they can be set to nil at some point during its lifetime. An optional type cannot be unnamed as well, because basically when you declare something as unnamed, you're saying that after this object has been set, it will always have a value, right? So that's why you cannot use optional types for unknown variables. And the same logic for the weak type. There is some advice from Apple. This is something that we found on documentation, actually, that basically says to use weak variables when it makes sense, actually, to this variable to become new at some point during its lifetime, right? And the same thing for the unknown. The only difference is that the unknown type, once it has been set, it will always have a value, right? So keep that in mind when working with weak and unknowns. So what are memory leaks, in fact? Basically, a leak is a portion of memory that has been allocated in memory and cannot be deallocated. That means that the operating system cannot use it, your program cannot use it, so that's a leak. And why leaks are so bad? Basically because when dealing with leaks, your app are going to receive lots of memory warnings, maybe from the operating system. And when dealing with that memory warnings, you can have like slowness, screen freezes, and even eventual crashes of your app. And all of that can be translated to bad reviews and ratings in the App Store, or user experience can be compromised as well. Here we wanted to talk about the main causes of leaks. They are not the only ones, of course, but basically the most common, I guess. There are retain cycles, closures, and notification center. And actually, the other types of leaks that we have, it's somehow a variation of retain cycles, right? Okay, so I'm going to show you some examples, so how to identify retain cycles, closures, and notification center, and after this, we're going to see how to fix them. So let's go with retain cycles. Basically, a retain cycle occurs when two classes, instances, hold strong references to each other, right? In a more practical way, if you take a look on this picture, we have object A and object B. Both of them have a strong reference to each other, right? In other words, if you say, if A retains B and B retains A, so you have a leak, right? Let's take a look on this code here. We have a class called country, which has a variable called capital city, which points to an object called city, right? So a country knows a city knows the country. When I do this, I'm holding references, strong references to those both classes, right? So in this case, I have a leak. For closures, basically, retain cycle in closures can also occur if you use instance variables inside of a closure's body, right? That's a little bit confusing when you read it, but let's see this code here. In this code, we have a variable called shtml that basically is a closure, as you can see. But in the body of that closure, we are using lots of self keyword there. When I do this, I'm creating a hold reference to this instance, right? So I'm creating a retain cycle here as well. For the notification center, basically it's the same thing of the closure, right? So, but it's most common for notification centers observers. So let's take a look on this code here as well. We have a method called addObserver that basically is calling the notification center to register this notification. Well, if you see best practices, it says that we should deallocate this notification once the object is deallocated, right, on the deinit function. The fact is, this function will never be called because in this closure's body, we are using self again. So we are holding a reference to self again. So in this case, the deinit method will never be called, and that's a leak as well. And now that we know the most types of leaks, let's see how we can identify them using some tools.
All right, so there's a few ways we can identify leaks. The first one is running an inspection, which can be very boring. I mean, imagining opening every class in your project and reading everything, you're going to miss something. So it's preferable to use tools. We have instruments provided with Xcode and the memory graph debugger. And we're going to see a little bit of those, of leaks and the memory debugger. Starting with this. So when you run your application, you can access the memory debugging in this toolbar. It's that little button that will lead you to this screen, which represents a memory snapshot. So, okay, you ran it, and you see this, which is literally a map of the object's allocation. So you have a few details when you click on every one of these symbols and boxes and stuff. There's stuff from the system as well, so you're not necessarily going to understand them. But there's a few things you can find interesting in this screen. For instance, in this sidebar, the left sidebar, you can see a list of every object that's alive in memory at that point of execution. So you see it listed by classes, and you have the number of instances of that class that are available at this point. So you can know, for instance, that we have, when this screenshot was taken, we have one view controller in memory. If you keep creating view controllers, you're going to see like 2, 3, 4, etc. So that's one way to find them. You can, for instance, to use this memory graph and this information to find leaks, like choose a flow on your application you want to test. Start your application on a clean state and take a memory graph and take a look at all the numbers of instances and what you have on that side panel. And then, okay, play again, well, not play again, continue execution, and then repeat this flow, like 1 time, 2, 3, how many times you want, and go back to the memory graph and observe a few things. For instance, should any of those instances have been deallocated already? For instance, if you go from one screen to the other, should an instance of the previous screen be in memory? Maybe not. And if it is, then you have a leak somewhere. Or the number of instances have increased. So if you go back and forth to a screen and you have various instances of that class, maybe you're creating new instances every time you go and go back. Or if the amount of memory has increased. If the answer is yes for any of those questions, then you have leaks in your code and you have to find them. Another good tool is instruments. And now you're going to use an example. It's a very simple checklists app. It's the basic functionality. You add a new item, you can toggle its checked state, you can edit it, and you swipe to delete. So it's just very simple, and we're going to use it to do a profiling. So let's profile this using leaks. You choose this option when, well, there's a lot of stuff you can do with instruments. It's a very good tool. We're going to use leaks today, and we're going to do these actions. Edit an item. Well, the video is not playing well. Edit an item, and then edit another. Add a new one. View one of them, but do nothing. And then delete item 5, and then go back and edit item 3. This should be playing, but, well, anyway. 5 of these steps have one thing in common. They're going to open the item detail view. So, oh, now it's playing. Nice. So yeah, just a few seconds to see what's being done, but anyway, like you see, and then delete, etc. If we take a look at the result of this profiling, we see this memory graph, and we see that it's increasing every time we open that item detail screen. So something's going on with this screen, and we have to find out why. If we check different points in time, we see that the memory used by any of these classes is increasing. So we know that they are probably the problem, and we see like the number of instances existing in memory. So you have like 5 persistent instances of the view controller and the presenter, so they're being held in memory. And also you have a lot of checklist items as well. And you have very many transient items, which means that they were allocated and then deallocated during the time lapse we're looking at. So it's fine, they were deallocated, but still we have a weird number there. If we check this, we see that exactly, we have memory going up for these classes. So 5 instances of view controllers and presenters, and 8 instances of items, and we only had 4 in the beginning. So what's going on here? I mean, the others are easy to identify. We went back and forth in the flow, but what about the checklist items? So if we take a look at the code for these, we have items being reassigned every time you look for the database, like to reload your screen. And when you open the detail screen, you get like a new instance from the SAGRI, and you set self as a delegate. But if you check the item detail view controller, you see that self is it's not a weak delegate, it's a strong reference. Also, you see that this detail screen has an item that's also a strong reference. So every time you reassigned item detail screen, you left like an orphan instance in memory because you have pointers to self, and so like there's a strong reference to that class, but it's no longer accessible because you reassigned the variable. So it's like lost in memory forever. You can never go back to it and deallocate it. So there you have it. That's why when we edited 3 items and created a new one, you have 4 manipulated items trapped to those item detail view controllers that are now lost in memory. That explains having 8 instances instead of 4. So, okay, we know how to identify leaks in a few ways. So, how do we fix them?
Let's see a little bit of that. Basically, for the examples that we brought here, there are 3 ways of getting rid of those leaks, right? Basically, break retain cycles using announced and weak types, reference types, and you can use a feature from Swift that's called closures capture list. So let's see how that works. So this is an example of, yep, no, not working, sorry. Okay, let's go. This is an example of how to break retain cycles using announced. So if you take a look on the same example that we saw before from the city and country, we have if A retains B and B retains A, then we have a leak. So in this example, a country knows a city and a city knows a country. That's a retain cycle, right? We can break this retain cycle using the unknown word. So when I'm declaring the country variable in the city class, I just put unknown before the declaration of the variable, and that breaks the cycle, right?
And semantically, it makes sense. Because, I mean, a city is going to exist while it belongs to a country. If you don't have a country, you kind of, I don't know, don't have a city. So during its lifetime, it makes sense that it belongs to a country, so it's okay to use a noun. It's used solely to break the retain cycle and not increase the reference count. It does nothing else to the semantics of your code. So that's why you would use a noun.
Exactly. Another way of breaking retain cycles is using the weak reference type. It's pretty common for us to see delegates in our code. That's a main cause of leaks as well. In this example here, we have a protocol that defines a method. And in another class, we have a reference to that delegate, right? When I put there delegate equals self, basically I'm creating a reference to self once more. A way to break that retain cycle is basically making your protocol or your definition of the protocol to extend from class. And when declaring this variable, this delegate variable, you use weak as well. And that will break your retain cycle as well. Another way of getting rid of leaks is using the Swift closures capture list. It's pretty common when you're working with reactive programming and closures in general. Basically, you define a pair, just getting back here. A capture list, it's a feature from Swift that allows you to define some rules when you are capturing some instance, right, inside of a closures body. So, they are basically a pair of variables using weak or announced, separated by commas, inside of square braces, right? You put them at the very beginning of a closures body to define those rules, right? In that case, I'm defining announced self and weak delegates from self delegate. So when I'm going to use the delegate in this case, I'm using the weak reference, not the strong one. And that breaks the retain cycle as well. If a closures body doesn't have a parameters list and a returning type, you can also put the unknown self or weak delegate or whatever, followed by the in keyword, and then you go with the body of the closure, right? And that breaks the retain cycle as well. And that's basically how we deal memory leaks, how we fix memory leaks.
No more.
No more.
We're safe.
Just doing a little recap here before we finish.
Yeah, so, I mean, memory leaks can be tricky to identify sometimes, but they're very easy to fix if you know where they are. You have a few types of leaks. All of them descend from retain cycles, basically, but you have different ways that they show up in your code, like closures, notification center. You would also have like self-references and arrays that generate strong references to objects. And you can break them with weak and unnowned.
Or you can use as well the Swift captures list, basically defining roles to retain those instances, right? You can use also Xcode memory debugger and the instruments, which are great tools as well to identify leaks. So you can see something more visual. You can see the memory growing. You can see number of instances, all the map in which instance were created, and this kind of stuff. And another tip here is to always profile your app and keep an eye on memory consumption. This will help you to identify those leaks and work on them. And that's all we have for today. Thank you.
Oh. Yes, thank you.